Add Excel Core Pure Matrices 3 Determinants and Inverses. Introduction to Inverse Matrices. So here we're looking for a matrix ABCD such that if we multiplied it by the matrix 2, 3, 1, 4 for example, we would get the identity matrix 1, 0, 0, 1. So the matrix ABCD would be the inverse of the matrix 2, 3, 1, 4. So if we did the multiplication, we would get the first element would be 2a plus 3c, 2b plus 3d, 1a plus 4c, and 1b plus 4d. And we want that matrix to be the identity matrix 1, 0, 0, 1. So if we pick out corresponding elements, so the first element would need to be 1, and if we pick out the element underneath it, a plus 4c would need to be 0, and then the top right element, 2b plus 3d would need to be 0, and b plus 4d would need to be the 1. If we solved the first two equations simultaneously, we would get a equals 4/5 and c equals minus a fifth. And if we looked at the next two equations simultaneously, we would get b equals minus 3/5 and d equals 2/5. So that means that the matrix we're looking for can be written as 4/5 minus 3/5 minus a fifth 2/5. So that's the matrix we're looking for. It's worth noting a couple of things. First, that we can take the fifth out as a common factor, so you may find that a more convenient way of writing this matrix that we're looking for. But the other thing to notice is if we multiply it by the original matrix, 2, 3, 1, 4, we get a fifth of, we get 8 take away 3, we get 12 take away 12, we get minus 2 plus 2, and we get minus 3 plus 8. So we do indeed get the identity matrix. It's also worth noting here that if we multiply the original matrix by ABCD, we get the same answer as ABCD times the original matrix. So we can see the solution there, and we can see the multiplication of the matrices at the end. So now we can start to think about the inverse of a 2 by 2 matrix in a bit more detail. So if the matrix 2, 3, 1, 4 is called T, then our new matrix is the inverse of T. And this would be written as T minus 1, the matrix T minus 1. And T minus 1 would be the inverse of the original matrix. So that is the matrix that we just found. So T times T minus 1 is the same as T minus 1 times T. They both would give you the identity matrix 1, 0, 0, 1. So a couple of things to note from this. Multiplying a matrix and its inverse is commutative, and this implies there is a unique inverse for a matrix. And the other thing to be aware of is that only square matrices have inverses. And later on in these recordings we'll be looking at the inverse of a 3 by 3 matrix as well. So here we have a matrix A and a inverse matrix, and we need to find the constants P and Q. So we know that if we multiply A by its own inverse, we would get the identity matrix. So that means if we multiply 2 minus 1, 2, etc., and we multiplied it by the inverse of A, then we would have to get the identity matrix. Now, we don't need to do a full multiplication here. All we need to find is P and Q. So if we focus, for example, on this element 1, that element 1 comes from top row times the first column. So that's 2 5s minus 1 times 1 and 2 P's. That's where that first element of 1 comes from. So P is minus 4. If we're looking for Q now, I'm going to focus on this top element there. So that's the top row times the third column. So we can do 2 times 7 minus 1 times Q, and 2 times minus 6 has to give me that element which is 0. So Q would be 2. We don't need to do all the other multiplications in this question to find the P and the Q. So in the next session we're going to be looking at the inverse and determinant of a 2 by 2 matrix.